Okay, student, this is the next video for Kinematics crash course for AP Physics, and let's start with the projectile motion. In projectile motion, there will be different cases, and I would be giving you directly formulas. So the first part is the dropping. In dropping, it means that some object is here and it goes down. And dropping means the initial velocity is zero. There is an object and I'm just not throwing it, but just leaving it up to God, and God has gravity here, so it goes downwards. So the acceleration here is equals to gravity. In these types of questions, first of all, this positive and negatives, this sign conventions is very important. Like, if there is no rule that you have to take it positive, but if you will take it negative, downwards will automatically positive. One will be negative, one will be positive. Okay, if you are taking it negative, it will be positive. If it is positive, it will be negative. So for this, initial velocity is zero. This case is called dropping. That height is given to you h. For that, v is equal to, that is the final velocity here, is equal to root 2gh. So this is the case of dropping. Now the next part is the time for this, and if you will calculate using the SWAT equations. So this is just a crash course, so I will just give you formulas for that. It will come like this. Okay, you just use the second SWAT equation for this, you will get it, because initial velocity is zero, like this, s equals to ut plus half ad square, where u is zero, this will go out, and this a becomes g, and this will multiply there, this will come down, and I have given you everything now. Okay, so now the vertical projectile. Vertical. In vertical projectile, it means that we are at here. Somebody has thrown this object down and it came back at the same position. So this is the top point. For this, always remember that the final velocity at the top will be 0 meter per second, because the body will go up and it will stop for just microsecond and then it will come back. So there will be initial velocity. Initial velocity wouldn't be zero. We have to put something. We have to put some efforts there. Then only the object will go up, and here it will be zero. So depending upon the SWAT equations you would be using, the h value would be u square by 2g. See, in all these questions we have to use only SWAT equations that I have already written in the previous video, that is v equals to u plus at, s equals to ut plus half at square, and v square equals to u square plus 2as. These three equations are very important. Remember them. A will be g, and you have to use the sign conventions accordingly. So when you will calculate the time will be 2u by g. See, this time is the whole of the time, total time. This time is from A to B. Sorry, this is AB. Okay, and then from A to C I have also calculated. It would be obviously same. A to C. Okay, yeah. This is A to C. This is the total time, and time A to B would be U by G. Okay. So this would be it will take half the time of the flight. So after the dropping and vertical, now we would be moving towards the horizontal projectile motion. That is the third part. So now, the horizontal projectile motion means that we are on a cliff and someone has put some efforts in the horizontal direction and this body is moving like this. So in this case, there will be some formulas that would be used. So you can use the SWOT equations for them. In these types of questions, always care about the vertical plane or the horizontal plane. Like the distance, the gravity will be always downwards. So for the vertical plane, gravity would be applicable. But for the horizontal, there is no gravity. So if it is with u, the velocity will always remains u. But on the downside, like we know that v equals to u plus at, and initial velocity would be 0 because this is in the x direction and in the y there is no velocity, so only gt would be there. Like this you have to see both of the planes. So I'm now just giving you the formulas for that. For that is t will be equals to 2h by g, and that will be the time of flight. And for the range value, that is that how much it would be going for that, you can use s equals to ut plus half at square. For that, if you would like to calculate this range, so r will be only ut because the acceleration will become 0, because acceleration, that is the gravity, is in the vertical plane, not in the horizontal plane. This r is in the horizontal plane. But if you want to calculate this height, then that is the height will be equals to ut. This ut will become 0 plus half at square. Then you have to use only this method formula. So in both of the cases, you will get the right answer. Always take care of the sign conventions. So if you are taking it positive upward, it would be negative downwards, or if we are taking negative upward, it would be positive downwards. So this is the horizontal projectile motion. And for this, like the final velocity, if you have to calculate this final velocity, you have to use the Pythagoras theorem, like, or you have to, we can say, the resultant of the vectors, whatsoever your teacher says. So r will be equal to u square plus gt whole square root. So this will be the velocity, that is a net velocity, we will say. So both of the components we have used. So these are the things that we basically discuss in horizontal projectile. So now we would be going for the last and the final, that is the oblique projectile. So in the oblique projectile motion, it means there is everything full projectile. It is starting from here and moving towards here. So here we will be having a u, that is the initial velocity, and we have a maximum value of height, and we have a range, that is r, that how much is the distance traveled. So you can use the SWOT equations to get the values. I'll just give you the time of flight formula, that is 2u sine theta upon g. So theta is the angle by this. So the velocity is making theta angle with the x-axis. And range formula is u square sine 2 theta. Okay, this is not square, this is 2 theta. This is into the bracket here and g is in the denominator. And the height formula is u square sine square theta upon 2g. So we got all the formulas here. The R maximum, that range maximum, it would be at when theta will be at 45 degrees, like this. If theta is 45 degree, we will have the maximum range. Now suppose if the theta is reduced, so it might go like this, so range will be less. So or if we reduce it, it could be like this. So if you are getting like this, there is a new formula for that, which says that theta 1 plus theta 2 will be equal to 90. So if theta 1 plus theta 2 is equal to 90, they will give you same range. So suppose this is 30 and this is 60, which is equal to 90. So if one person is throwing with 30 degrees, it will reach like this of the range, and another person throws the projectile with same speed. Okay, u is same, so it will go, height will increase but range will remain same. So these are the things that you have to take care of this in this. And one more thing, yeah, in the projectile motion, if you will create some parallel lines through the plane, the velocity here, that is the vp, will be equals to vq if this point is q. So these are all the points that we have covered. So with this, kinematics is over. All the distance, displacement, and projectile, everything is complete. And now we would be moving for the forces motion. So hope this video has cleared your doubt and now you are getting prepared for your exams. Okay, thank you for being here. If you still have some doubts or you want some feedback, definitely put it in your comment section. Thank you for being here.